Hello and welcome to the sleepy universe. Asterisk, asterisk, as the night deepens, ponder a hidden reflection, a universe of opposites. Every particle might have a twin, an exact mirror image, waiting. It hints at a fundamental duality, a profound balance in existence, as the day gently fades, and the world outside begins to quiet its busy hum. You find yourself drifting into a space of stillness. The sounds of the day recede, becoming soft echoes in the distance. Your breath deepens, a soft, slow rhythm, like the quiet lapping of waves on a distant shore, or the gentle sigh of the wind through ancient trees. Feel the peaceful weight of your body, sinking deeper into comfort, deeper into rest. This moment, this quiet space, is yours. Tonight, we embark on a journey not through distant stars or into the quantum realm, but into the very fabric of reality itself, to explore a truth so profound it feels almost like a secret whispered by the universe. We are going to discover that for every particle of matter that makes up you, your bed, the earth, and every star in the sky, there exists a hidden reflection, a universe of opposites. This is the astonishing world of antimatter. Imagine, if you will, that everything you see, everything you touch, has an exact twin, a mirror image that is identical in almost every way, except for a crucial difference. It's like looking into a perfectly polished mirror. You see your reflection, a perfect copy, but left is right and right is left. Antimatter is precisely this, a mirror image of ordinary matter, identical in mass, but opposite in fundamental properties like electric charge. As you lie here, comfortable and still, allow your mind to gently open to this extraordinary idea. It is not about magic, not about science fiction, but about the deepest, most fundamental rules of our universe, pushed to their absolute limits. This concept hints at a fundamental duality, a profound balance in existence that permeates the cosmos, from the smallest subatomic particles to the grandest galaxies. Consider a familiar pair, a magnet. It has a north pole and a south pole, two opposites that are intrinsically linked. Or think of positive and negative numbers, two sides of a mathematical coin that perfectly balance each other. Antimatter is like this, an inherent opposite to every particle of matter. Every particle might have a twin, an exact mirror image, waiting to be discovered, or perhaps waiting to meet its counterpart. This concept means that for every electron, a tiny particle with a negative electric charge, there exists an anti-electron, also known as a positron, which has the exact same mass but a positive electric charge. For every proton, a positively charged particle in the nucleus of an atom, there is an antiproton with the same mass but a negative charge. And for every neutron, a neutral particle, there is an antineutron, which, though electrically neutral, has opposite magnetic properties and is made of oppositely charged constituent particles called antiquarks. As you continue to breathe deeply and evenly, imagine these pairs of opposites constantly existing, constantly interacting, even if we don't directly perceive them in our everyday lives. They are woven into the very fabric of reality, a testament to the universe's elegant symmetry. This profound balance in existence suggests that for every something, there is an anti-something, a perfect counterpart. Let this thought settle gently in your mind, like a soft blanket settling over you. The universe is a place of incredible balance, of fundamental symmetries, and antimatter is one of its most striking examples. It's not just a theoretical construct, it's a real, tangible form of matter, observed and studied in laboratories around the idea of antimatter might seem strange, given that our universe appears to be made almost entirely of ordinary matter. If antimatter is the perfect opposite, why don't we see vast galaxies made of it? This is one of the universe's greatest riddles, a question that has puzzled scientists for decades, and one we will explore later in our journey. As you drift, imagine the quiet presence of these opposite twins, constantly existing, constantly interacting. Even if we don't directly perceive them in our everyday lives, they are woven into the very fabric of reality, a testament to the universe's elegant symmetry. This profound balance in existence suggests that for every something, there is an anti-something, a perfect counterpart. Feel the quiet hum of the night and the gentle rhythm of your own breath. Just as your body has two sides, left and right, seemingly symmetrical yet distinct, so too does the universe possess this fundamental duality. Antimatter is a reminder that reality is far more complex and awe-inspiring than we often perceive. It is a testament to the universe's capacity for elegance, even in its most extreme forms. Rest now in the knowledge of this profound mystery. The universe is a place of endless wonder, and even its hidden reflections hold secrets that illuminate the very nature of existence. Let the quiet understanding of this hidden reflection guide you deeper into peaceful slumber. For as we delve deeper into the nature of these opposite twins, we will explore the subtle ways their properties are reversed, a mirror image of matter's essence in the particle's mirror. Asterisk, as you continue to drift, softly, deeply, allow your awareness to journey even further, beyond the familiar world of ordinary matter, into the subtle distinctions of its opposite. We have imagined antimatter as a hidden reflection, a twin to every particle. Now we drift closer to the very essence of this mirror image, exploring how its fundamental properties, like electric charge and spin, are perfectly reversed. A subtle shift that defines its unique nature. Imagine a particle, perhaps an electron, with its tiny, negative electric charge, and its intrinsic property of spin, like a tiny top rotating in a specific direction. Now, picture its antimatter twin, the positron. It has the exact same mass, the same size, but its electric charge is precisely opposite, positive, and its spin, while still present, is also perfectly reversed, like a top spinning in the opposite direction. Here, charge and spin are perfectly reversed, a subtle shift that makes all the difference. This inversion of properties is what truly defines antimatter. It's not just a different type of particle, it's an exact opposite, a negative image that perfectly complements its positive counterpart. Think of a photograph and its negative. The negative contains all the same information as the photograph, but the light and dark tones are inverted. Where the photograph is bright, the negative is dark, and vice versa. Antimatter is like the negative of matter, holding all the same fundamental information, but with key properties inverted. This is a world of inverted properties, a digital echo of form. For every type of particle that exists in our universe, there is a corresponding antiparticle. Quarks, the tiny building blocks of protons and neutrons, have antiquarks with opposite charges. Neutrinos, those ghostly, almost massless particles, have antineutrinos with opposite-handedness, a property related to their spin. The universe, at its most fundamental level, is built on these complementary pairs. As you listen, imagine these inverted properties. They are not just theoretical concepts, they are precisely measured and confirmed in particle accelerators. Scientists can create antiparticles and study their behavior, confirming that they behave exactly like their matter counterparts, except for these crucial inversions. Consider a pair of perfectly matched gloves. One is for your left hand, the other for your right. They are identical in material and design, but their handedness is opposite. Antimatter and matter particles are like these gloves, perfectly matched, but with an inherent opposition in their fundamental characteristics. This subtle shift in properties is what makes antimatter so unique and, well, as we will soon explore, so incredibly powerful. It's this precise opposition that leads to the most dramatic event in the universe, when matter and antimatter meet. That as you breathe softly and deeply, let this profound idea settle. The universe is built on a foundation of opposites, a delicate balance of positive and negative, left and right, matter and antimatter. This inherent duality is a testament to the universe's elegant symmetry, a silent echo of form that permeates all of existence. Feel the quiet precision of these inverted properties. They are not random, they are perfectly balanced, ensuring that for every fundamental attribute of a particle, there is an exact opposite in its antipode. This symmetry is a cornerstone of our understanding of particle physics, a beautiful and intricate design woven into the fabric of reality. As you drift deeper into slumber, allow your mind to contemplate this world of inverted properties. It is a reminder that reality is far more complex and symmetrical than we often perceive, and that even the smallest distinctions can hold profound implications. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This digital echo of form, this subtle shift in properties, is what sets the stage for the most explosive event in the universe. For when these perfect opposites finally meet, they don't just cancel out, they annihilate each other in a flash of pure energy, a cosmic embrace unlike any other. As you continue to drift, softly, peacefully, let your mind now turn to the most dramatic and powerful event involving antimatter, annihilation. We have explored antimatter as the mirror image of matter with perfectly reversed properties. Now, imagine the moment these perfect opposites finally meet, in an explosive embrace that releases pure energy, brilliant and swift. Imagine a single particle of matter, perhaps an electron, gently drifting through space. Now imagine its antimatter twin, a positron, drifting towards it. As they draw closer, their opposite charges pulled them together, an irresistible attraction. The moment they touch, they don't just cancel each other out like positive and negative numbers. Instead, they vanish, they are gone, and in their place, a burst of pure energy erupts, typically in the form of high-energy light particles called gamma rays. This is the rhythm of ultimate contact, an explosive embrace unlike any other. When matter meets its twin, pure energy bursts forth, brilliant and swift. It is the ultimate conversion of mass into energy, far more efficient than any chemical reaction or even nuclear fusion. According to Albert Einstein's famous equation, E equals mc, a tiny amount of mass can be converted into an enormous amount of energy. Antimatter annihilation is the most perfect demonstration of this principle. Think of a tiny spark igniting a colossal explosion. The amount of matter and antimatter involved might be infinitesimally small, but the energy released is immense. For example, if you could annihilate just 1 gram of antimatter with 1 gram of matter, it would release as much energy as a large nuclear bomb. This is a dance of cosmic proportions, a final, irreversible transformation where matter and antimatter cease to exist as particles and instead become pure energy as you breathe. Softly and deeply, let this profound image settle. This annihilation is not destructive in a negative sense. It is a fundamental process in the universe, a perfect conversion. It is how the universe recycles mass into energy, a continuous dance of creation and transformation. Consider two perfectly balanced dancers spinning towards each other. When they meet, they don't crash. Instead, they dissolve into a brilliant flash of light, leaving behind only the radiant energy of their combined motion. The annihilation of matter and antimatter is like this, a beautiful, energetic conclusion to their existence as particles. This flash of pure energy is what scientists use to detect and study antimatter. When antiparticles are created in particle accelerators, they quickly encounter ordinary matter and annihilate, producing characteristic gamma rays that can be detected. This allows scientists to confirm the creation of antimatter and to study its properties. The energy released during annihilation is incredibly potent. It is the most efficient known energy source in the universe. This has led to dreams of future technologies, such as antimatter-powered spacecraft that could achieve incredible speeds, or antimatter energy generators that could provide limitless, clean power. These remain distant dreams, as creating and storing antimatter is incredibly challenging and expensive, but the potential is immense. As you drift deeper into slumber, allow your mind to contemplate this explosive embrace. It is a reminder that the universe holds forces of unimaginable power, and that even the smallest particles can unleash immense energy when they meet their opposites. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This dance of cosmic proportions, this final, irreversible transformation, is one of the most dramatic consequences of antimatter's existence. But if matter and antimatter are created in equal amounts, and their meeting results in such a powerful flash, why is our universe seemingly made almost entirely of matter? This leads us to one of the greatest unsolved mysteries in cosmology, the Big Bang's riddle. As you continue to drift, softly, peacefully, let your mind now turn to one of the most profound and perplexing questions in all of cosmology. We have explored the explosive embrace of annihilation, where matter and antimatter meet in a flash of pure energy. Now we confront a fundamental riddle that arises from the very beginning of our universe, the Big Bang's riddle. Where did the antimatter go? Imagine the very first moments of our universe, just after the Big Bang. It was an incredibly hot, dense, and energetic place. According to our best theories of particle physics, in those earliest fractions of a second, matter and antimatter should have been created in almost perfectly equal amounts. For every particle of matter, there should have been a corresponding antimatter. So, if matter and antimatter annihilate each other in a flash of pure energy, then shortly after the Big Bang, the universe should have been filled with an immense burst of radiation, as all the newly created matter and antimatter met and destroyed each other. And if they were created in exactly equal amounts, then nothing should have been left behind. No matter, no stars, no galaxies, no you. But here we are. Our universe is filled with galaxies, stars, planets, and people, all made of ordinary matter. There is very little antimatter naturally occurring in the cosmos today. This is the profound cosmic riddle from the universe's dawn. Equal parts born, yet only matter remains, a vanishing act. It's a mystery of cosmic imbalance, bending the very fabric of creation. Think of a perfectly balanced scale. If you put exactly the same weight on both sides, they remain level. The early universe should have been perfectly balanced between matter and antimatter, but somehow the scale tipped. A tiny, almost imperceptible imbalance must have occurred, leaving behind a minuscule excess of matter, perhaps. Just one extra particle of matter for every billion pairs of matter and antimatter that annihilated. This tiny excess, this subtle asymmetry, is what allowed our universe to exist. After the initial annihilation, that tiny leftover amount of matter was enough to form all the stars, galaxies, and everything else we see today. It's a testament to how crucial even the smallest imbalance can be on a cosmic scale. As you breathe softly and deeply, let this profound idea settle. This cosmic imbalance is one of the greatest unsolved problems in physics. Scientists call it the baryon asymmetry problem. Why did matter win? What fundamental process or force operating in the very early universe favored the creation of slightly more matter than antimatter? Consider a cosmic coin toss, where the coin is designed to land on heads and tails an equal number of times. But somehow, after billions of tosses, you find that there are always slightly more heads left over. The Big Bang's riddle is like this: a fundamental bias in the universe's initial conditions that allowed matter to survive. Scientists are actively searching for answers to this riddle. They are conducting experiments at particle accelerators, like the Large Hadron Collider, to study the fundamental properties of particles and antiparticles with extreme precision. They are looking for tiny differences in how matter and antimatter behave, subtle violations of symmetry that could explain the cosmic imbalance, theories involving new particles, new forces, or slightly different decay rates for matter and antimatter. In the very early universe are being explored. These theories attempt to explain how that crucial, tiny excess of matter could have been generated, ensuring that our universe, made of matter, could come into being as you drift deeper into slumber. Allow your mind to contemplate this mystery of cosmic imbalance. It is a reminder that the universe holds secrets from its very beginning, profound questions about its origins that continue to challenge our understanding. It is a testament to the universe's capacity for both immense power and incredibly intricate, long-term processes, this bending of the very fabric of creation, this vanishing act of antimatter, is a fundamental aspect of our universe's story. But even though antimatter is rare in our everyday world, scientists have learned how to create it, harnessing immense energy to produce these elusive particles in their laboratories. As we continue our journey, we will explore this remarkable feat, delving into how we create the anti-world, particles in a bottle. As you continue to drift, enveloped by the quiet stillness, let your mind gently envision a remarkable feat of human ingenuity. We have explored the Big Bang's riddle, the mystery of antimatter's cosmic disappearance. Now we turn to the present day, two quiet laboratories where scientists are actively creating and studying antimatter, crafting tiny anti-worlds, holding elusive particles in a bottle. Imagine immense, complex machines, deep underground or in specialized facilities. These are particle accelerators, powerful instruments that can smash particles together at nearly the speed of light. When these collisions occur, the immense energy involved can briefly transform into new particles, including pairs of matter and antimatter. So antimatter is born in these quiet labs, not spontaneously from nothing, but from the conversion of energy into mass, following Einstein's famous equation. For example, when high-energy protons collide, they can produce a shower of new particles, including protons and antiprotons, electrons and positrons. This is how scientists produce the building blocks of antimatter. But creating antimatter is only the first step. The real challenge is to contain it. Remember, when matter meets its antimatter twin, they annihilate in a flash of pure energy. So, you can't store antimatter in a regular container because it would instantly annihilate with the atoms of the bottle. This is where the delicate art of containment comes in. Antimatter is held in magnetic fields. A delicate art. Scientists use powerful magnetic fields to create invisible bottles or traps that can suspend antiparticles without allowing them to touch any ordinary matter. These are called magnetic traps or penning traps. The charged antiparticles are guided and held in place by the magnetic forces, floating in a vacuum, never touching the walls of their container. Think of a tiny, invisible cage made of pure magnetic force, holding a single, elusive firefly without letting it touch the sides. The scientists carefully adjust the magnetic fields, ensuring the antiparticles remain suspended, isolated from anything that could cause their annihilation. This is a testament to incredible precision and control. As you breathe softly and deeply, let this profound image settle. The ability to create and contain antimatter, even in tiny quantities, is a monumental achievement of modern physics. It's a view that challenges perception, revealing humanity's ingenuity in pushing the boundaries of what is possible. It allows scientists to study antimatter's properties with extreme precision, comparing it to ordinary matter to look for any subtle differences that might help solve the Big Bang's riddle. Consider a cosmic alchemist, not turning lead into gold, but turning pure energy into matter and antimatter, and then holding that elusive antimatter in an invisible embrace. This is the essence of what happens in these advanced laboratories. The quantities of antimatter created are incredibly small, typically just a few thousand antiparticles at a time, existing for mere fractions of a second, or, with advanced traps, for minutes or even hours. It takes immense energy and resources to produce and contain even these tiny amounts. This is why antimatter is the most expensive substance on Earth, far more valuable than gold or diamonds. As you drift deeper into slumber, allow your mind to contemplate these tiny antiworlds. They are a reminder that even the most exotic and elusive particles can be brought into existence and studied, revealing profound truths about the fundamental nature of reality. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This creation of anti-worlds, these particles in a bottle, is a testament to humanity's ingenuity in unraveling the universe's secrets. But the true allure of antimatter lies not just in its scientific mystery, but in its incredible potential for energy. For as we continue our journey, we will explore the dream of limitless power, the immense energy released when matter and antimatter meet, a power beyond imagination. Let your mind now stretch to the most captivating promise of antimatter, its potential as an energy source. We have explored how scientists create and contain tiny amounts of antimatter. Now, imagine the immense power released when matter and antimatter meet. A dream of limitless energy, a force truly beyond imagination. Imagine a future where our energy needs are met not by burning fossil fuels, or even by nuclear fission or fusion, but by the ultimate conversion of mass into pure energy. This is the promise of antimatter. Remember, when a particle of matter meets its antimatter twin, they annihilate, transforming their entire mass into energy. Following Einstein's famous equation, E equals mc squared, beyond the abyss, all paths lead to immense power. The efficiency of antimatter annihilation is truly astonishing. If you could annihilate just 1 kilogram of antimatter with 1 kilogram of matter, it would release more energy than the largest nuclear bombs ever detonated, or enough to power a major city for years. It's the universe's ultimate fuel, a profound potential at its core. Think of a tiny, compressed spring that when released unleashes an incredible amount of force. Antimatter is like this, but on a fundamental, subatomic level. The spring is the mass of the particles, and when they meet their opposites, that mass is instantly converted into a burst of pure energy. This dream of limitless energy is incredibly appealing. If we could harness antimatter efficiently, it could revolutionize our energy production, providing clean, abundant power without any waste products. It could solve the world's energy crisis and dramatically reduce our environmental impact as you breathe. Softly and deeply, let this profound idea settle. The efficiency of antimatter energy is unparalleled. Nuclear fission, used in power plants, today converts only about 0.1% of mass into energy. Nuclear fusion, the power of the sun, converts about 0.7%. Antimatter annihilation, however, converts 100% of the mass of both particles into energy. This makes it the most efficient energy source known to humanity. Consider a tiny, concentrated battery that holds more power than entire power plants. Antimatter is like this, an incredibly dense store of energy waiting to be unleashed. The challenge, of course, is creating and storing enough of it to be practical currently. The amount of antimatter we can create is infinitesimally small, measured in mere atoms or a few thousand particles at a time. The energy required to create even these tiny amounts far exceeds the energy released during their annihilation. So, while the potential is immense, the practical application of antimatter as a power source is still a very distant dream, requiring breakthroughs in production and containment technologies. As you drift deeper into slumber, allow your mind to contemplate this power beyond imagination. It is a reminder that the universe holds secrets of energy that are far more profound than our current technologies allow us to harness. It is a testament to the universe's capacity for both immense power and incredibly intricate, long-term processes. This profound potential at its core, this dream of limitless energy, is a powerful inspiration for scientists and engineers. It pushes them to explore the fundamental laws of physics, hoping to unlock new ways to create and control this elusive substance. The next time we meet in this quiet space, we will explore another tantalizing possibility for antimatter, its potential to revolutionize space travel, propelling us to distant stars on journeys powered by this explosive twin, as we consider antimatter as cosmic fuel. Its potential to revolutionize space travel. We have explored its immense energy potential. Now, imagine this explosive twin not just as a source of power on Earth, but as the cosmic fuel that could propel us to distant stars, nurturing exploration across the vastness of the universe. Imagine a starship, sleek and powerful, not burning chemical rockets, but fueled by tiny amounts of antimatter. When matter and antimatter annihilate, the energy released is so enormous that it could accelerate a spacecraft to incredible speeds, far beyond what traditional propulsion systems can achieve. This is the promise of antimatter propulsion. It might power starships, propel us to distant worlds, nurture exploration across the cosmos. The efficiency of antimatter annihilation means that you would need only a tiny amount of fuel to generate immense thrust. This would dramatically reduce the mass of fuel needed for long-duration space missions, making interstellar travel, journeys to other star systems, a more feasible dream. Think of a tiny, incredibly efficient engine that can provide limitless power for a journey across an ocean. Antimatter propulsion is like this, but on a cosmic scale, offering the potential to traverse the vast distances between stars in a fraction of the time it would take with conventional rockets. As you breathe, softly and deeply, let this profound idea settle. The concept of antimatter rockets has captivated scientists and science fiction writers for decades. It represents a leap in propulsion technology that could truly open up the galaxy to human exploration, allowing us to reach exoplanets, study distant nebulae, and unlock even more secrets of the universe. Consider a tiny, incredibly potent pill that gives you boundless energy for an entire day. Antimatter fuel is like this, a highly concentrated form of energy that could provide the immense power needed for interstellar journeys. However, the challenges are immense. As we discussed, creating and storing antimatter is incredibly difficult and expensive. We can currently produce only picograms, trillionths of a gram of antimatter, which is far too little for any practical propulsion system. Developing the technology to produce and store significant quantities of antimatter, and then to safely control its annihilation for thrust, represents a monumental engineering feat. But the dream itself, the potential for antimatter to sculpt the future, is a powerful inspiration. It pushes scientists to continue their research into fundamental particle physics, hoping that breakthroughs in understanding and manipulating antimatter could one day make interstellar travel a reality. It's a hidden, powerful hand in discovery, guiding our exploration of the universe's most extreme phenomena. As you drift deeper into slumber, allow your mind to contemplate these journeys to the stars. It is a reminder that the universe holds possibilities that stretch far beyond our current technological capabilities, and that human ingenuity is constantly striving to reach for the impossible. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This immense energy sculpting the future, propelling us to distant worlds, is a tantalizing vision. But beyond these grand, futuristic dreams, antimatter is already playing a surprising role in our lives, offering a gentle glow that aids healing, revealing subtle truths within the body in the medical whispers of antiparticles. *1 that is already quietly aiding healing in our world. We have explored antimatter's explosive power and its potential for cosmic travel. Now, imagine a faint whisper, a gentle glow from the anti-world, used not for destruction, but for revealing subtle truths within the body. Imagine a patient undergoing a medical scan, not with X-rays, but with a tiny, controlled stream of antimatter. This is the reality of positron emission tomography, or PET scans, a powerful diagnostic tool used in hospitals around the world. In a PET scan, a very small amount of a radioactive substance that emits positrons anti-electrons is introduced into the patient's body. As these positrons are emitted, they travel only a very short distance before encountering an electron, a particle of ordinary matter within the patient's tissues. When the positron and electron meet, they annihilate, producing two high-energy gamma rays that shoot off in opposite directions. These gamma rays are the gentle glow from the anti-world, a silent signal revealing subtle truths within the body. Antimatter aids healing by allowing doctors to see what's happening at a molecular and cellular level, long before structural changes become visible on other types of scans. By detecting these gamma rays, computers can reconstruct a detailed three-dimensional image of the body's internal activity. This allows doctors to detect diseases like cancer, heart disease, and brain disorders in their earliest stages, when they are most treatable. Think of a tiny, invisible beacon placed inside the body that lights up when it finds a specific type of cell activity. The positrons are like these beacons, and their annihilation with electrons creates the light that allows doctors to see. This is a paradox of destruction for good. The very process of annihilation, which is so powerful and explosive on a large scale, is harnessed in a controlled, microscopic way to provide invaluable diagnostic information. A tiny amount of antimatter is used to destroy an equally tiny amount of matter, but the energy released is precisely measured and used for healing. As you breathe, softly and deeply, let this profound idea settle. The use of antimatter in medicine is a testament to how fundamental scientific discoveries, even those that seem exotic or dangerous, can be applied for immense human benefit. It's a reminder that the universe's most extreme phenomena can be tamed and utilized for precise and life-saving purposes. Consider a delicate surgical tool that uses a tiny, precise burst of energy to target only the diseased cells, leaving healthy tissue untouched. While not a direct analogy, it captures the idea of using a powerful force with incredible precision for beneficial outcomes. The positrons used in PET scans are produced in special facilities and have very short half-lives, meaning they decay rapidly. This ensures that the patient is exposed to minimal radiation and that the radioactive substance quickly leaves the body. The careful path forward in using antimatter involves rigorous safety protocols and precise control. As you drift deeper into slumber, allow your mind to contemplate these medical whispers. It is a reminder that even the most theoretical and seemingly dangerous aspects of physics can find practical, life-saving applications. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This paradox of destruction for good, this gentle glow from the anti-world, is a powerful example of scientific ingenuity. But even with these amazing applications, the fundamental question remains: why is there so little antimatter in our universe today? This leads us back to the cosmic imbalance, a profound asymmetry that continues to puzzle scientists, holding creation's secret. Let your mind now return to one of the most fundamental and persistent mysteries of our universe. We have explored antimatter's properties, its explosive annihilation, and its surprising medical uses. Now, we confront the core enigma, the universe's imbalance, a profound cosmic asymmetry that silently sleeps at the heart of existence. Imagine a perfectly balanced scale, where for every grain of sand on one side, there is an identical grain on the other. Our best theories suggest that at the very beginning of the universe, during the Big Bang, matter and antimatter should have been created in exactly equal amounts. For every particle, a corresponding antiparticle. If this were truly the case, then, as the universe cooled, all matter and antimatter should have annihilated each other, leaving behind a cosmos filled only with light and no particles. But here we are. Our universe is overwhelmingly made of matter. Stars, galaxies, planets, and you, all composed of ordinary matter. Antimatter, its twin, is incredibly scarce in the cosmos today, found only in tiny splitting amounts produced by high-energy cosmic rays or in specialized laboratories. This is the profound imbalance, the cosmic mystery. Matter dominates. Its twin scarce. Think of a cosmic coin toss, where the coin is rigged, but only slightly. For every billion times it lands on heads matter, it lands on tails antimatter. Just a tiny bit less frequently, or perhaps it decays slightly differently. This minuscule, almost imperceptible bias in the very early universe is what allowed matter to win, to survive the initial annihilation, and to form everything we see. Around us, this cosmic asymmetry is one of the greatest unsolved problems in physics. Scientists call it the baryon asymmetry problem. Baryons are particles like protons and neutrons, which make up most of the mass of ordinary matter. Why did matter prevail? What fundamental process or force, operating in the first tiny fractions of a second after the Big Bang, favored the creation of slightly more matter than antimatter? As you breathe softly and deeply, let this profound idea settle. This imbalance is the reason our universe exists in its current form. Without that tiny excess of matter, there would be no stars, no planets, no life. It is a testament to how crucial even the smallest deviation from perfect symmetry can be on a cosmic scale. Consider a perfectly symmetrical dance, where every step taken by one dancer is perfectly mirrored by another. But imagine if, just once, one dancer took a slightly different step, and that tiny deviation led to the entire dance evolving into a completely new, complex choreography. The universe's imbalance is like that single, crucial, asymmetrical step that allowed creation to unfold. Scientists are actively searching for the answer to this riddle. They are conducting ultra-precise experiments at particle accelerators, looking for tiny differences in the behavior of matter and antimatter. They are exploring theories that involve new, fundamental particles or forces that might have existed in the very early universe, creating the conditions for this asymmetry. These theories often involve subtle violations of fundamental symmetries, tiny biases in the laws of physics that allowed matter to gain a slight advantage. As you drift deeper into slumber, allow your mind to contemplate this cosmic asymmetry. It is a reminder that the universe holds secrets from its very beginning, profound questions about its origins that continue to challenge our understanding. It is a testament to the universe's capacity for both immense power and incredibly intricate, long-term processes. This cosmic mystery, holding creation's secret, is a quiet, profound puzzle that continues to inspire. It reminds us that our understanding of the cosmos is always evolving, always deepening, and that there is always more to discover. Even in the most fundamental aspects of reality, the next time we meet in this quiet space, we will explore the surprising instances where antimatter does appear naturally in our world, fleeting glimmers that remind us of its constant presence, even if scarce, in the subtle dance of nature. Now turn to a surprising truth. Even though our universe is dominated by matter, antimatter is not entirely absent from our daily lives. We have explored the cosmic imbalance, the mystery of antimatter scarcity. Now, imagine fleeting glimmers, tiny antiparticles appearing and vanishing around us. A subtle dance of creation and annihilation that occurs naturally, even on Earth. Imagine, for a moment, a tiny, invisible spark of light appearing and disappearing in the air around you. This is like the spontaneous creation of positrons, anti-electrons, in various natural processes. These tiny antiparticles are naturally occurring, a subtle dance that reminds us of the universe's fundamental symmetries. One of the most common ways antimatter appears naturally is through the decay of certain radioactive elements. Some unstable atomic nuclei, in their attempt to become stable, undergo a process called beta plus decay. In this process, a proton inside the nucleus transforms into a neutron, and in doing so, it emits a positron and a neutrino. These positrons are then quickly annihilated by electrons in the surrounding matter, producing gamma rays. This is the same process harnessed in medical PET scans. Think of a tiny, invisible firefly that briefly flashes into existence, then vanishes. In a puff of light, these naturally occurring positrons are like these fireflies, appearing and vanishing. A fleeting glimmer that confirms the constant interplay between matter and antimatter. Even in our seemingly ordinary world, another source of natural antimatter is cosmic rays. These are high-energy particles, mostly protons, that originate from distant stars, supernova, and other violent cosmic events. When these cosmic rays collide with atoms in Earth's atmosphere, they can generate showers of new particles, including pairs of electrons and positrons, and protons and antiprotons. These antiparticles are then quickly annihilated by ordinary matter in the atmosphere. But their brief existence is a testament to antimatter's constant presence. As you breathe softly and deeply, let this profound idea settle. Even in our universe, the fundamental laws of physics ensure that antimatter is constantly being created, albeit in tiny, fleeting amounts. It's a memory of Earth's grand cycles, a unified ancient dream of creation and annihilation that continues to play out around us. Consider a single drop of water falling into a vast ocean. It briefly creates a ripple, then is absorbed back into the larger body. These fleeting antiparticles are like those drops, appearing briefly from the cosmic flow, then quickly returning to the sea of energy through annihilation. Even thunderstorms can produce antimatter. During powerful lightning strikes, electrons can be accelerated to very high energies, and when they collide with atoms in the atmosphere, they can produce positrons. These positrons then annihilate with electrons, generating bursts of gamma rays that can be detected from space. This is a truly astonishing example of antimatter being generated in our own atmosphere. As you drift deeper into slumber, allow your mind to contemplate these fleeting glimmers. It is a reminder that the universe is full of hidden processes, subtle dances of particles that constantly shape our reality, even if we are unaware of them. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This subtle dance, these tiny antiparticles in our own world, are a testament to the universe's ceaseless transformation. But while antimatter is constantly being created, it is incredibly difficult to capture and hold. As we continue our journey, we will explore the ingenious methods scientists use to trap these elusive particles, delving into the antimatter trap, holding the explosive twin. Now stretch into the cutting edge of scientific endeavor. We have explored the fleeting glimmers of antimatter in nature, its spontaneous appearance and rapid annihilation. Now imagine the immense challenge and the ingenious solutions involved in capturing and holding this elusive substance, the antimatter trap, holding the explosive twin. Imagine a tiny, invisible cage, not made of solid bars, but of pure magnetic force. This is the essence of an antimatter trap. Since antiparticles have an electric charge opposite to their matter counterparts, they can be manipulated and contained by powerful magnetic fields. This is how scientists manage to hold the explosive twin, preventing it from touching any ordinary matter and annihilating, beyond the present, envisioned traps for the explosive twin. The most common type of trap, used to store antiprotons and positrons, is called a penning trap. It uses a combination of strong electric and magnetic fields to create a magnetic bottle that can suspend charged antiparticles in a vacuum. The particles are essentially bounced back and forth between electric fields, while the magnetic field keeps them from drifting sideways and hitting the trap walls. Think of a tiny, charged ball bearing suspended in mid-air by an invisible force field, never touching the ground or the sides of its container. The antimatter trap is like this, a marvel of precision engineering and fundamental physics. Magnetic fields contain it, shaping future technologies. The ability to trap antimatter, even for relatively short periods, minutes, hours, or even days, for small quantities, is crucial for studying its properties. Scientists need to hold it still, cool it down, and observe it without it annihilating. This allows them to compare antimatter to matter with extreme precision, looking for any tiny differences that might explain the universe's matter-antimatter imbalance. As you breathe softly and deeply, let this profound image settle. The technology required to create and maintain these traps is incredibly sophisticated. They operate in ultra-high vacuum environments, cooled to temperatures just a fraction of a degree above absolute zero, to minimize any stray atoms that could cause annihilation. This is a testament to human ingenuity in pushing the boundaries of what is possible. Consider a delicate cosmic ballet, where invisible forces guide tiny dancers, keeping them perfectly suspended and isolated. The antimatter trap is like this, a precise choreography of electromagnetic fields designed to cradle the explosive twin without allowing it to touch its annihilating counterpart. The ultimate goal of some experiments is to create and trap entire antiatoms, like antihydrogen and antiproton, orbited by a positron. This is even more challenging, as antihydrogen is electrically neutral, making it harder to trap with electric fields alone. Scientists use complex magnetic configurations, like magnetic minimum traps, to hold these neutral antiatoms. This hints at endless transformation, a grand, evolving design. The breakthroughs in antimatter trapping technology are not just for fundamental research. They are also essential steps towards the futuristic applications we discussed, like antimatter, propulsion for interstellar travel, or antimatter energy generation. The ability to safely store and manipulate antimatter is the key to unlocking its immense potential as you drift deeper into slumber. Allow your mind to contemplate these antimatter traps. They are a reminder that even the most elusive and dangerous substances can be tamed and controlled by human intellect and ingenuity. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This grand, evolving design, holding the explosive twin, is a powerful testament to humanity's relentless pursuit of knowledge. But even with the ability to create and trap antimatter, a colossal mystery remains. If antimatter is a mirror image, could there be entire galaxies, vast cosmic structures, made entirely of antimatter? This leads us to the ultimate cosmic quest, the search for anti-galaxies. Now expand to the grander scale of the antimatter mystery. We have explored the creation and trapping of tiny amounts of antimatter in our labs. Now, we ask a colossal question. How does the universe balance its matter, its twin? Could anti-galaxies drift, vast and silent, in the cosmic void? This is the search for anti-galaxies, a truly cosmic quest. Imagine looking out into the night, sky, seeing countless stars, nebulae, and galaxies, all made of ordinary matter. But what if, hidden in the vastness, there were entire galaxies, immense collections of stars, planets, and dust, made entirely of antimatter? These would be anti-galaxies, mirror images of our own, made of antiprotons, antineutrons, and positrons. Could anti-galaxies drift, vast and silent, in the cosmic void? This is a profound question that has intrigued astronomers for decades. If the Big Bang created equal amounts of matter and antimatter, and if the tiny imbalance only occurred locally in our observable universe, then perhaps there are distant regions of the cosmos where antimatter won, forming anti-galaxies. Think of a vast ocean where, in one region, the water is blue, and in another, it is red. If the universe were perfectly symmetrical, we might expect to see large regions of antimatter, but the evidence suggests otherwise. As you breathe softly and deeply, let this profound idea settle. If an anti-galaxy were to collide with a matter galaxy, or even if a single anti-star were to encounter a cloud of ordinary gas, the resulting annihilation would release an immense burst of gamma rays. These gamma rays would be incredibly powerful and distinctive, a clear signal of matter-antimatter annihilation on a cosmic scale. However, despite decades of searching, scientists have not detected any such large-scale annihilation events. The gamma-ray background radiation in the universe is relatively smooth, without the powerful, localized bursts that would be expected from matter-antimatter collisions between galaxies. This suggests that if anti-galaxies exist, they must be incredibly rare or incredibly far away, beyond our current observational limits. This is a profound interplay, a silent, continuous partnership between theory and observation. Our theories suggest that antimatter should be abundant, yet our observations show it to be scarce. This discrepancy is what drives the cosmic quest, pushing scientists to refine their models of the early universe and to develop even more sensitive detectors. Consider a vast dark forest. You are searching for a specific, rare type of glowing flower. You know it should be there, but you haven't found it yet. You continue to search, using better tools, exploring new areas, hoping for that telltale glimmer. The search for antimatter is like this, a patient, persistent quest for a subtle cosmic signature. Some theories suggest that if antimatter regions do exist, they might be separated from matter regions by vast, empty voids, preventing annihilation. Other theories propose that the initial imbalance was truly universal, meaning that the entire observable universe is indeed matter-dominated. As you drift deeper into slumber, allow your mind to contemplate these vast, silent anti-galaxies. It is a reminder that the universe holds mysteries on the grandest scales, and that our understanding of its fundamental composition is still evolving. It is a profound and humbling reminder of the universe's capacity for both immense power and incredibly intricate, long-term processes. This silent, continuous partnership between matter and its twin, whether balanced or imbalanced, is a fundamental aspect of our universe's story. But even when matter and antimatter meet in a flash of pure energy, a profound puzzle remains. What happens to the information contained within them? This leads us to the deepest mystery of all, the information paradox of annihilation, and what the universe remembers. Settle on one of the most profound and perplexing questions in all of physics, a mystery posed by the very act of matter-antimatter annihilation. We have explored the explosive embrace when matter and its twin meet, releasing pure energy. Now, we confront a fundamental puzzle. What happens to the information contained within them? This is the information paradox of annihilation. Imagine a particle of matter, perhaps an electron. It has specific properties, its mass, its charge, its spin, its momentum. All of these properties represent information about that particle. Now, imagine it meets a positron, its antimatter twin, and they annihilate in a flash of gamma rays. The particles are gone, transformed into pure energy. A profound puzzle lingers. What happens when matter and antimatter meet? The gamma rays, produced to carry energy and momentum. But do they carry all the specific information about the original particles? If information is truly conserved in the universe, as quantum mechanics strongly suggests, then the unique properties of the original electron and positron should somehow be encoded in the resulting gamma rays, or in some other form. But it's not immediately clear how this information is preserved. If it simply vanishes, then it would violate one of the most fundamental principles of physics, the conservation of information. This principle states that information can never be truly destroyed, only transformed or scrambled. If information were truly lost in annihilation, it would challenge physics' deepest laws, creating a profound conflict within our understanding of the universe. Think of a complex, intricate sandcastle. You build it with specific shapes, towers, and details. Then a wave washes over it, turning it back into a pile of wet sand. The sand is still there, but is all the information about the castle's specific structure truly gone? Or is it subtly encoded in the way the sand grains are now arranged, theoretically recoverable if you had infinite knowledge? The information paradox asks this question about particles and their annihilation. This is a mystery of what the universe remembers. If the universe is a giant cosmic computer, as some theories suggest, then every interaction is a computation, and information is never truly deleted. But annihilation seems to be a perfect reset button, turning specific particles into generic energy. How does the universe keep track of the details? As you breathe, softly and deeply, let this profound puzzle settle. It's a question that has occupied the minds of the greatest physicists for decades. While the annihilation itself is well understood, the fate of the information contained within the annihilated particles is a subject of ongoing debate and research. Consider a beautifully crafted glass sculpture. If you smash it into tiny fragments, the glass is still there, but the specific shape of the sculpture seems lost. The information paradox asks if the shape of the particles, their unique quantum states, is truly lost in the fragments of energy, or if it's subtly encoded in a way we don't yet fully comprehend. Scientists are exploring various theoretical possibilities to resolve this paradox. Some suggest that the information is indeed preserved, perhaps encoded in the quantum properties of the emitted gamma rays in ways that are incredibly subtle and difficult to detect. Others propose more radical ideas, suggesting that perhaps our understanding of information or space-time needs to be fundamentally revised. As you drift deeper into slumber, allow your mind to contemplate this mystery of what the universe remembers. It is a reminder that even in the most fundamental processes of creation and destruction, there are profound questions about the nature of reality, about what is truly fundamental, and about the very essence of existence. This mystery of what the universe remembers is a quiet, profound puzzle that continues to inspire. It reminds us that our understanding of the cosmos is always evolving, always deepening, and that there is always more to discover, even in the most fundamental aspects of reality. As we conclude our journey through the wonders of antimatter, Let the immensity of these cosmic questions and the beauty of the universe's intricate design gently guide you into the deepest, most peaceful slumber. For in the boundless embrace of the cosmos, all mysteries find their quiet rest. Asterisk, as the final whispers of antimatter's magic softly fade, and the last threads of this cosmic story gently unravel, you find yourself completely enveloped in the peace of deep sleep. Your breath is slow and even, a gentle rhythm that mirrors the quiet pulse of the cosmos. The thoughts of mirror particles, of explosive annihilation, of cosmic riddles, and of hidden energy now blend into a seamless, comforting hum within your mind. You have journeyed through the astonishing realm of antimatter, a world where every particle has an opposite twin, and where their meeting results in a flash of pure energy. You have glimpsed the unfolding mystery of existence, from the subtle shift of charge and spin reversed to the profound puzzle of why our universe is dominated by matter. Each step of this journey has revealed a deeper layer of truth, a more profound understanding of the universe and your place within its intricate design. Remember the explosive embrace of annihilation, the ultimate conversion of mass into energy, a dance of cosmic proportions. You have pondered the Big Bang's riddle, the mystery of why matter won, and the profound cosmic asymmetry that allowed our universe to exist. You have also explored how scientists are creating tiny anti-worlds in quiet labs, holding elusive particles in magnetic traps, a testament to humanity's ingenuity. And you have considered the immense potential of antimatter as a dream of limitless energy, a cosmic fuel that might one day power journeys to the stars. You have learned about the surprising medical whispers of antiparticles, aiding healing and revealing subtle truths within the body through PET scans. And you have discovered the fleeting glimmers of antimatter that appear naturally around us, a subtle dance of creation and annihilation in nature. Finally, you have contemplated the deepest puzzle of all, the information paradox of annihilation, a mystery of what the universe remembers when matter and antimatter meet. This question challenges physics' deepest laws, pushing us to explore the very essence of information and reality. This knowledge is not meant to be a burden, but a source of deep comfort and wonder. It reminds you that you are not separate from this duality of existence, but an integral, interconnected part of it. The same profound forces that govern the dance of matter and antimatter also resonate within your own being, a constant, quiet reminder of your place in the grand scheme of things. As you sink deeper into this duality of existence, release any lingering thoughts, any remaining questions. There is no need to grasp every intricate detail. Simply allow the feeling of profound unity to wash over you, a gentle wave carrying you further into peaceful slumber. The universe, in its infinite wisdom, holds its mysteries gently, inviting us to wonder, to explore, and ultimately to rest. In its boundless embrace, let the universe's quiet magic lull you deeper into sleep. This magic is the ceaseless creativity of existence, the silent rhythm of fundamental interactions, the subtle dance of opposites that balances the cosmos. It is the force that allows particles to exist, energy to be released, and the universe to unfold in all its intricate beauty. This magic is not outside of you. It is within you, around you, and in every single thing that exists. You are a part of this unfolding mystery. Your very presence, your consciousness, your capacity for wonder are all manifestations of this incredible cosmic dance. There is a deep harmony between your inner world and the outer universe, a reflection that invites you to feel utterly at peace, utterly connected. Rest now in this comforting knowledge, as the sleepy universe holds you gently until morning.